Welcome back, Daniel here, of course, and in this lecture we're going to talk about a JVM specific concept, the exceptions. Alright, back to the IDE, let's create a new Scala application. So right click, part 2 OP, new Scala class, let's call this exceptions. Make this an object, of course, okay, and then finally extends app. Cool, so exceptions are a technical and very sweet name for the miserable situation where your program crashes. So for example, if I declare a val, x, which is, say, a string, we don't really care, but from some method or from some other piece of code returns null, and if I try to print line x.length or something, then that will crash my program. So let me switch to presentation mode so you can see my context menus. So if I right click and run this, this will crash my program with the famed null pointer exception. Now the technical translation for this absolutely crappy situation is that this method length, when accessed or when called, throws the null pointer exception and nobody's there to catch it. And so the JVM will crash. So the technical terms are throwing and catching exceptions. So before continuing, let's comment this out and say this will crash with a null pointer exception. So let's find out how to throw exceptions. You can throw an exception by using the keyword throw, new, let's say null pointer exception. This is an expression that throws an exception. So if I right click and run this, I'm going to crash my program, this time intentionally. So this is an expression that throws an exception, and because there's nobody there to catch it, this will crash the program. Like everything else in Scala, throwing an exception is an expression. Alright, so this can be assigned to things. If I say val a weird value equals throw new null pointer exception. This is a valid value for a real value, except that this expression returns nothing. So if I hover over a weird value, it says a weird value is nothing. So this doesn't actually hold a value, but can be assigned to things. So if a weird value is of some other kind, let's say a string, this is also a valid substitute because nothing is a valid substitute for any other type. Now, if you've never dealt with Java or the JVM before, you may wonder why the new thing here. Well, the thing is that exceptions are actually instances of classes, nothing more. So null pointer exception is actually a class. I'm instantiating it, and I'm throwing an instance of null pointer exception. Now, the property of a class to be throwable is restricted by that class extending or deriving from the throwable type. So throwable classes extend the throwable class. Deriving from throwable are exceptions, so the type exception, and error are the major throwable subtypes. Both exceptions and errors will crash your JVM, but exceptions and errors are different in their semantics. So exceptions denote something that went wrong with the program, for example, a null pointer exception. Errors denote something that happened wrong with the system. For example, a Stack Overflow error that you've probably seen in the recursion lecture, that is something that went wrong with the JVM because you exceeded the memory of the JVM stack. Alright, so you now know about exceptions, what they are, how to throw them. Let's discuss about how to catch exceptions. So you now know how to throw exceptions. I'm going to call this 1, throwing exceptions. And here we'll discuss about how to catch exceptions. Alright, so let's define a small method. Let's call this, actually I'm going to write this on this line. So def get int. And this receives a parameter, let's say with exceptions, which is a boolean. All right, we want to trigger whether this method throws exceptions or not. And this returns an int. And the implementation is going to be if with exceptions, then throw an exception. Throw new, let's say, runtime exception. And runtime exceptions usually also get a message as a class parameter. Let's say no int for you. Otherwise, let's just return the value 42. The way that you would guard against an exception from this method is to use a try-catch expression. So the way that you would do that is to write try and then open and close curly brace. And inside you write your code that might fail. Let's say get int with the parameter true. And after the curly brace, the keyword catch, and then another curly brace. And in here, we are going to try to match what kind of exception might be thrown in here. So we're going to say case, let's give this a name. So e colon runtime exception, and then an arrow sign, and then let's print something to the console. Caught a runtime exception. All right. And finally, notice the finally is also a keyword. And here we have a code that will get executed. Will get executed no matter what. Okay, so let's print line the string finally. All right, so this is the whole syntax for try, catch, finally expressions. So inside the try block, you put in your code that might throw an exception. In the catch block, you try to match against all exceptions that you might have. And then finally, you will put in your code that will get executed no matter what. So let's try to run this program. So, we threw a new null pointer exception. Yes, let's comment this out, right? Because this will crash our program. All right, now let's run this again. Good, so we have caught a runtime exception and finally. So get int with the parameter true tries to throw a runtime exception, right? But it got caught in the catch block right over here, and it got matched against this pattern. So the case E runtime exception is a good pattern for the exception that got thrown. So this on the right hand side, this expression got evaluated, which had the side effect of printing this to the console. And then finally, we printed the string finally to the console because this will get executed whether or not the exception is or is not caught. Let's try to change the pattern. Instead of runtime exception, let's try to catch a null pointer exception and see what happens. Now, because we're matching against a null pointer exception, the runtime exception that actually gets thrown in here will not get caught. So this will crash our program. So if we right click and run this, this should crash, of course. So with a Java long runtime exception with no int for you, this is the message. But finally, the string was printed out no matter what. Now, if you've paid very close attention to this error message right over here, you saw probably the fully qualified name for the runtime exception, which is Java lang runtime exception. So if you saw that, then your suspicions are true. Exceptions come from the Java language, and they are a JVM specific thing, not a Scala specific thing. Cool, now let's talk a little bit more about this try catch finally expression because it's a little bit more complicated. So, like everything else in Scala, the try catch finally is an expression. Now, what is the value of this try catch finally, you may wonder? Well, let's try to assign this to a val. Let's call this potential fail. Equals, and the value of the potential fail is this whole try catch finally shenanigan. So, potential fail is, drums rolling, any val. Well, that's because the try block tries to return an int. So the value returned by getInt is an int, but the value returned from catching the null pointer exception which is this print line statement, is unit. So when the compiler tries to unify int and unit, it gets any val. If, for example, when catching the null pointer exception, I return the value, say 43, and let's change this back to runtime exception, then the type of potential fail will be an int, because the try block returns an int, and all the catch blocks, or all the catch cases, return int. So the compiler unifies int with int and just figures out that potential fail is an int. All right, so if I actually print line potential fail, I'm actually going to see the value 43. Right. If we call getInt with the value false, which means that this guy does not throw exceptions, then I'm going to see the value 42 to the console. Of course. But the finally string was printed regardless, which brings me to the important idea that the finally block is optional. And also, finally does not influence the return type of this expression. So use finally only for side effects. For example, logging something to a file. When you write distributed applications, you might want to do that. All right, so you now know what exceptions are, how to throw them, and how to catch them. Now, let's talk about how to define your own exceptions. So like I said at the beginning, exceptions are instances of special classes that derive from exception or error. You rarely need in practice to derive a class from error. You most usually need exception. So if I declare a class called myException, which extends exception, then I can actually create a new exception of course, as I would of any other class, and then I can just throw it, throw exception. So if I right-click and run this, this will crash my program with a myException. And your custom exceptions, because they are classes like any other classes, they can have class parameters, they can have fields, they can have methods, they can have whatever you expect from a regular class. Although you rarely need that in practice. At most, you usually need a name or a print stack trace utility method, but that's probably 99% of the use cases. You rarely need anything else. All right, so let's practice. I want you to do some small exercises. First, I want you to crash your program with an out of memory error. Out of memory errors happen when you want to allocate more memory than the JVM has. All right. I want you to crash with a Stack Overflow error. You've seen this before, and this is probably easier to do. And now I want to define a little pocket calculator. So this will be a class with a couple of methods that basically adds two numbers. These are all int for simplicity. Multiply and divide. Also, let's add the subtract method. So add, subtract, multiply, and divide. So these methods are going to be extremely simple, with the exception that these methods will throw a custom exception if something wrong happens. So per case, we'll throw an overflow exception that you are going to implement if add xy exceeds. So if add xy exceeds int.maxValue, underflow exception if subtract xy, and also add xy if x and y are negative. So exceeds int.min value. All right. And math calculation exception for division by 0. So pause the video and work through these, and I'm going to get back with solutions right now. So I hope you worked through the exercises. It probably required a bit of a search online, especially with the out of memory error, but I'm going to dispel the mystery right now. So how to crash your program with out of memory error? Basically, you need to allocate more memory that the JVM has available. So if I define an array that has too many elements, I can use array.ofdim to allocate an array with as many elements as I want. So let's say I allocate int.maxValue elements of type whatever I want. This will crash the JVM. All right, so this will create an out of memory error. Requested array size exceeds virtual memory limit. All right, so this is how you crash your JVM with an out of memory error. This is also called colloquially and quite affectionately an OOM. Now, I think the stack overflow error is easier to solve, and it's by defining an infinite recursive method. So if I define infinite, which say it returns an int and returns 1 plus infinite, then this will create a stack recursion. And if I assign this to a val, let's call this no limit, and call it infinite, then running this will crash the program with a stack overflow. And the stack trace is extremely big because we've exceeded the Java stack limit. All right, so this is how you crash your JVM with the beloved stack overflow. Now, for the pocket calculator, this is going to be pretty easy. So let's call this pocket calculator. Pocket calculator. And actually, let's make this an object. It's not really relevant or important, but I don't want to instantiate pocket calculator every time I actually call its methods. So let's define the add method, which receives two parameters, x and y, both integers. And normally, this returns x plus y, because this is what adding does, right? But if x plus y actually exceeds the integer representation, then we should throw an overflow exception, or underflow if both x and y are negative and x plus y is actually less than integer min value. Now there's a problem with that because we can't really compare say x plus y versus int max value. So what I mean by that is that, let's say val result is x plus y, we can't really compare if result bigger than int dot max value, because this is basically false all the time. This is the max value that the integer type can have. So result will never be greater than int dot max value. What we actually need to test is that if x plus y is bigger than max value, then this result will suddenly turn negative. So watch what happens. Say I actually delete this and return result, just for the sake of example, and I just print line pocket calculator dot add, and I add int dot max value and say the value 10. Right? So I'm adding 2 billion something and 10. Watch what the result is going to be. Negative 2 billion something. All right? So a positive value plus a positive value giving a negative value means that I've overflown integer. So basically, if x bigger than 0 and y bigger than 0 and result less than 0, then I'm going to throw a new overflow exception that I haven't actually defined. Let's define the class. Class overflow exception extends runtime exception, for example. You can use any exception type that you want. Also, let's define the underflow exception that were on the subject. This extends runtime exception as well. All right, so if two positive values added result in a negative value, then we throw an overflow exception. If, or otherwise if, both elements are negative and the result is positive, then a symmetrical event happens. That's called an underflow. So we are going to throw a new underflow exception. All right. Otherwise, we'll just return result. Let's put this in an else clause. All right. So the code flow will not complete. Okay. If the overflow or underflow happen, then we're going to throw these exceptions and the program will crash. A symmetrical thing will happen with subtract. Let's say x is an int, y is an int, and we have a symmetrical implementation. So say result is x minus y. We're going to be very careful with the conditions here. So if x is bigger than 0 and y is less than 0 this time around, then that means subtracting x from y means adding two positive numbers. And the result is less than 0, then we're going to overflow. Otherwise, if x is less than 0 and y is bigger than 0, then that means I'm adding two negative numbers, and if in this case result is positive, then I'm going to throw an underflow exception. Else result. Okay, so very, very similar. Now, why does the compiler underline? Oh, useless expression. Why is that? Oh, because I've defined it as a unit, of course. Okay, we might just like delete the return type altogether. All right. Okay, let's multiply. And again, this is also something that we're going to deal with in terms of conditions. So let's say result is x times y. So if x is bigger than 0 and y is bigger than 0, and all of a sudden result is less than 0, then overflow. But this also happen if I have two negative numbers yielding a negative number, because normally two negative numbers multiplied should result in a positive number. Now, if the signs are inversed and yet the result is positive, then we are dealing with underflow. So let's put some else statements here. Else, and I'm going to paste the conditions, and we're going to change them right now. So if x is bigger than 0 and y is less than 0, so the signs are inversed, and the result is not negative, it's positive, then we're dealing with underflow. And underflow, and vice versa. So it's if x is less than 0 and y is less than 0 and the result is positive, then again we're dealing with underflow. Otherwise, result. Okay, so this is how we would do an exception savvy pocket calculator. And the divide is pretty simple. So if divide x is an int, y is an int, and the implementation is going to be if y is equal to 0, then throw new division by 0, which we called math calculation exception. So class math calculation exception extends runtime exception. And let's, for the sake of variation, let's call this division by 0 and pass it to runtime exception. Division by 0. All right, because runtime exception also has a constructor that has a string as a parameter. Okay, so we are going to throw math calculation exception, otherwise x divided by y. Okay, so let's print this out. So if I try to print pocket calculator dot divide, and I try to divide the numbers 2 and 0, I'm going to get this super math calculation exception that we defined. Oh, so what am I seeing? Oh, I'm seeing the overflow exception because the add method is now exception savvy. So let's comment this out and let's run divide now. Okay, so we have math calculation exception and the message division by 0. So our methods work correctly. Congratulations. Okay, quick recap. You now know that exceptions are these miserable little things that crash your program. You now know how to throw exceptions and the fact that throwing an exception returns nothing. You now know how to catch exceptions with try, catch, finally expressions, and you now know how to define your own exception by deriving exception or error or the throwable types from Java. Cool, so you now know how to intentionally crash your program. I'm Daniel, and I'll see you in the next video.